Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, we're going to do all things math for your teacher certification exams. So welcome back to those who join me every week, and to those that are new. This is an informal math session where we go through 10 math problems that are designed to cover, a little bit of everything on your teacher certification exams for your math. So for the next hour, we're going to go over 10 problems. We're streaming live on YouTube and our Facebook channel. So some of you are watching this live, some of you are watching the recording, which is great. So just to let you know, if you're watching live, you can go ahead and comment in the comment section below, either on YouTube or Facebook, and I will try and get to your questions because I want to make sure that we get those answered for you. And if there is a question, if you have something that you need an answer on and you're not watching me live, then just go ahead, shoot me an email, info@KathleenJasper.com, or put it in the comment section, because we look at the comment sections too, and just to make sure that everything is good to go. So I'm just making sure that everybody is up on the channel and it's looking good on my end. Let me just double check how we're doing on Facebook. And then we're just going to jump right into the problems. So if you haven't noticed, the problems, there are 10 of them, are linked in the section below, either the Facebook page or the YouTube channel. So you can get those problems, you can print them out, you can follow along, or you can just print them out and use them as practice problems for yourself. So looks good everywhere. And I think we're going to go ahead and get started. So, like I said, these problems are going to, it's not particularly one test or one set of competencies. It's more along the lines of just kind of generic math. I've got some algebra, I've got word problems, got a little bit of geometry, and then it's just little tips and tricks that I can show you to just get the right answers and be as efficient as possible as you're taking your math tests, because that's the name of the game. I'm not here to teach you step by step the foundations of math and all this and that. My goal, my purpose, my objective is to get you to get the right answer at least 75% of the time in the time allotted for your test. So timing is a big issue and a big factor for most of you. That's usually what holds a lot of you back. And so it's just important that you practice your studying correctly. My two tips are, number one, always have scratch paper. You got to understand that when you're taking this test, you're taking it on a computer and you're not able to write. Like, I'm not allowed to highlight the 3 and the 4, and I'm not allowed to underline anything like a lot of you do when you practice on paper, because you have the problem right in front of you. It just makes it easier. You need to get to a point where you're only using scratch paper, where you look at the problem and then you write everything down that you need to on scratch paper and then go from there. So that's an important study tip. And that'll also help you with your time management, because if you go into it always knowing you can highlight words and see, you can't do that on the computer test. So it's gonna throw you for a loop. And then the second thing is use your calculator. Find out what calculator you get for the test, learn how to use that calculator correctly, and then use it. This is your tool. This is going to save you a lot of time. Instead of a lot of you want to do things in your head. You want to scratch things out, do long division, do all this stuff, when you can just do it on your calculator. And most of you, like 90% of you, get a calculator on your test if it's a math portion of the test. Okay. So those are my two things that I always kind of say at the beginning of these sessions. All right, let's just go ahead and roll right into it. So we've got this first problem here. It says, if x over 6 is between 3 and 4, which of the following could be the value of x? So I like these problems because they're not too difficult, but the way that they're written, and it's just not a problem you're used to seeing as far as, a lot of you want just straight math problems or a straight algebra problem. And sometimes they just don't give that to you. So you just have to make sense of these problems. And again, what's easy for some may not be easy for others and vice versa. So if I've got x over 6 is between 3 and 4, well, let's just go ahead and kind of write it. If x over 6 is equal to, let's say 3, right? Well, how do we solve this? We'll do the same thing here. X over 6 is equal to 4, because we got to have some sort of range. So the way that we go about doing this is, well, I can do any number of things, but I want to get rid of this 6 because you got to get x by itself. So this 6 is being divided, the x is being divided by 6. So we want to counteract that. We want to do the inverse operation, which would be to multiply by 6. And if we multiply by 6 on one side, we got to do it to the other. So see how that 6 goes away, and I've got 8x is equal to 3 times 6 is 18. So I've got 18 here, and I'll do the same thing here, 6. I've got x is equal to 24. So the question says it has to be between 3 and 4. So between 3 and 4 would be 18 and 24. So just look, what's the only numbers here that are greater than 18, less than 24, and you've got C, which is 20. Okay, so it's just, setting it up correctly, and then between 3 and 4 is where you want to be. Sometimes when it says, greater than 3, less than 4, and let's say that it had 18 and 24 as an answer, you wouldn't pick 18 or 24, right? Like if this said 18, I wouldn't pick 18 because it says, if it would have said greater than, and this is equal to 3 or 4 would be 18 or 24. So just be careful when you see different variations of a question like this, when it's got between, greater than, less than, all that kind of stuff. All right. Okay. The next one here, I like this one because this can be a challenging problem for a lot of people. And so when I teach this in my geometry classes, it's just real simple and straightforward. So the way that this goes is it says figure ABCDE is similar to figure VWXYZ. Which proportion must be true? Okay. If it's giving you this statement, this is called a similarity statement. Number one, because it says similar, and it's given it to us in the letters of the shapes. This is how we name these shapes. This A, B, C, D, that means I start at A and I go to B, C, D, E, and then back to A. That's my polygon right here. All right. So, excuse me. So the way that they have it, like A, B, C, D, E, and V, W, X, Y, Z, is the order in which they both match up. Okay. So that means if I write this, and this is how you should write similarity statements, you should take it as they named it, because they said A, B, C, D, and E. And then they gave you V, W, X, Y, Z. Understand, I wrote it right on top of each other because those are your corresponding sides. Instead of looking at the letter, like starting at A and then going A to B, okay, A to B. So you see A to B is here. Which one of these in this shape is similar to A to B? Well, when we write it the way I showed you, or how they name it, it's VW, V to W. So see how these two are similar? They're not the same. They're just, one is bigger by so many times than the other, or one is smaller by so many times than the other. That's what it means to be similar. So I know that AB and VW, they correspond. And you see it right here. AB A over V, B over W. So that's why I stack these on top of each other, because when they give us the answer choices, I need to figure out which ones of the proportion are true. So this is our proportion. A, B, C, D, E over V, W, X, Y, Z. Those are similar. So now let's just match these up. So let's start with A. A says AE over XY. So I have AE over XY. So do those match up? And they do not, because they would have been right on top of each other. So I know for a fact that's not going to work. So that's out. Okay. So then the next one, I have AB over VW, AB over VW. Okay, that works. So we're good there. YZ. Okay, now here's where YZ over DE. Here's DE. So it looks like they match up, right? But you've got to be careful, because it went from, I'm just going to go with our congruent statement so you can see it. Or similarity statement, sorry. So this one is a go, but see how we went top over bottom? This is bottom over top. Does that make sense? I did YZ over DE. That is not a similarity statement, because it's got to go top over bottom, top over bottom. Okay. So this is not right because of that. And that's why, even though they look like they're right on top of each other, the pattern has to be the same. If it starts AB over VW, that was these two over this one, these two over this one, which means you have to go top, bottom again. All right. That's very important when we're looking at these proportions. So C says BC over XY, BC over XY. That's not going to work because they don't correspond. The only thing that corresponds is C over X. And that doesn't work because you got to have both of them in order for it to be correct. So by process of elimination, we see that D has to be the correct answer. So if we go AB, which is this here, over VW, which is this, okay, so top, bottom, then CD, that's this one, over XY, over this one, and you'll see that that is a correct proportion for these two figures, which are similar to each other. So 2 is going to be D. So just make sure when you get similarity or congruent. Now, why is this not a congruent statement? And there's differences between the two, but a congruent statement is going to have values. So this would have had like 4, that's not 4, 3, 2, 8, 7, 2, 6, 3, 1, right? Then if you had values, you would get the congruent statement. Also, similarity statement, you'll see, I'll just do this one. So like AB is similar to VW as opposed to AB. This is congruent. Okay. What is the top? It's the top. I haven't drawn one in a while. But a congruent statement would be where it's the squiggly on top of the equals and then VW. Okay. That's the difference of what it'll say. It really has no bearing on this problem. The most important thing is just matching up the correct sides so that you get the proportion done correctly. Okay. Next one, we've got Paula completely covered a square wall using 87.5 square feet of wallpaper without any overlap. Which measurement is closest to the side length of this wall in feet? Okay, so how are we going to figure this one out? We've got the area, that's 87.5. And it says it's a square. So what do we know about squares? So if I draw a square, and mind you, it's not going to be perfect, the area is equal to 87.5. Well, what do we know about squares? squares have all sides the same, x, 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 x. So if I know what the side lengths are, in this case I do because it's algebra and I put a variable there, and I know the total, which is 87.5, well, then I can figure out what the side length is. So I can do, well, what do we do for area? Area is equal to length times width, or base times height. So I can do x times x equals 87.5. X times x is x squared, not 2x, is equal to 87.5. How do we figure this out? If you're getting this problem, you're going to have a calculator to use. So all you have to do is take the square root of 87.5, and you will get 9.4. It says which measurement is closest. So these are always key when we do problems like this, because 9.4, which is what's the closest? It's multiple choice. So what's in the ballpark? Well, in this case, 9 is in the ballpark because it says which is the closest. It didn't tell you round to the nearest something. It just said which number is closest. And 9.4 is closer to 9 than any other number in these answer choices. Okay. All right, this one, I picked this one for a reason. Ben collected data from a group of 12 people. He measured each person's resting heart rate and recorded the average number of hours each person exercised each week. He created a scatter plot to show the data he collected. Here's our scatter plot. Based on the scatter plot, what is the best prediction of the resting heart rate in beats per minute of a person who exercises on average 8 hours a week? So you can see we have the scatter plot. And with this scatter plot, we can say, well, there's a pretty good direction that it's going in. We can do a best line of fit. So we could kind of magically take some line and go right in between all the dots. And if you had a ruler, it'd be easier. But remember, you can't do this on your test because you don't have the ability to write on the screen. You can take your pencil, so a pen or pencil, and line it up with it on the screen. You can't see what I'm doing here, but you line it up on the screen where you think that imaginary line would go, and that might help you as well, because we need to get to this 8-hour mark, which is here. So I need to be in this region here. So when it's giving us our answer choices, know that you're going to be in this area, and let's see how the answer choices play in. So the first one says 30 beats per minute. So if I'm on 8, I know that 30 is right here. So that doesn't look like, based upon the way that the dots are clumped together and going in the direction that they're going, this doesn't feel like it's going to be the next one. So I'll just leave that there. The next one says 50 beats per minute. So 50 would be right here. Okay, looks pretty good. The next one says 55 beats per minute. So 55 is going to be right above it, like here. And then the next one says 60. Okay. So let me see if I can. So these are really close, 50, 55, and 60. Let's go 50. 55. And then 60. Okay. So I feel pretty confident that this is out, right? That's not going to work because of the way it's going. So the way that I like it going is that as it keeps going on the line here, that it's going down. So I like it here over the 50 because 55 and 60 are just a little too high. Could they be on that line? Sure, they could, but we're looking for the best possible prediction. And as these go down, you see that this last dot here is pretty similar to this one. So it's trending down. We want to get the next one that's down closest to those dots. And that's why we're going to take that red one. This one's going to go away because it's just too far down. Now, this is a best guess scenario. You know, you could argue for the green dot if you wanted to. I mean, you can honestly argue for the blue dot, but out of all three of them, the red dot, which is 50 beats per minute, is definitely going to be the best choice. And that's how you got to think of this problem. Okay. So it's weird when you can't really tell 100%, there's a little bit of doubt there. That can be dangerous. So just go with the best one that you can. Okay. Next one, we have a right triangle and two of its side lengths are shown in the diagram. Which measurement is closest to the value of X in centimeters? So we've got ourselves a good old fashioned right triangle where we have two sides and we're missing the third. So what do we do when we have a right triangle and we have two out of the three sides? We do the old infamous Pythagorean theorem, which is a squared plus b squared equals c squared. I'm pretty sure this is on formula sheets, but this is something that you should know. You should know the Pythagorean theorem, where the sum of the squared sides is equal to the squared hypotenuse. So these are a and b. They're interchangeable. They can be a or b here, or they can be a and b here. It really doesn't matter, just as long as you know where they go when you do the equation. So the way we want to set this up is we'll make it 12 squared plus x squared equals 39 squared. Okay. So that's our side lengths squared. So it's 144 plus x squared equals, I should know this one. I think it's 1521. Yep, 1521. Next, we subtract the 144. Okay, this is good practice going through the motions of this, but ultimately you're going to want to do shorthand as much as you can, do mental math, do calculator math, try and keep your steps down to a minimum so that you save time. And all that does is just take practice. So you can Google search Pythagorean theorem problems and you can just practice until you get really good at these and you can solve this problem in just a couple minutes. So I've got this 1521 minus 144 is going to give me 1377. X squared is equal to, now we know the last thing we do is once we get everything to one side, the X, it's X squared, which means we need to square root it. And that's just one click of the button. Every calculator that you get for your test has to have a square root button. Okay, they can't expect you to do square root by hand. That's crazy. So the square root of 1377 ends up being X equals 37.1. We need to go with the closest value in centimeters. And it looks like they've nailed it for us with A. A is going to be the correct answer. It's 37.1 centimeters for this side length right here. Okay, so that's Pythagorean theorem. Make sure you know Pythagorean theorem. Sometimes it's just straight up where they give you the sides. So that's easy. Just square both of them and then add them together. But this is what it looks like when you're missing a side. Get X by itself, or in this case, X squared by itself, and then square root everything. And that's your answer. Okay. All right. Next one, we've got the weights in pounds of 7 packages are listed below. There we go. The weight of an 8th package is added to the list. The mean weight of the 8 packages is 12 pounds. What is the weight in pounds of the 8th package? Okay, So what we've got is our packages. That's what these values represent here. And then they give us an eighth one, but we don't know what that eighth one weighs. But then it says all 8 have a mean of 12 pounds. So what is mean? Mean is average. So we're going to have to use average to solve this problem. So the first thing I want to do is do a couple of different things. I want to take the sum of all of these, which ends up being 25, 10, 20, 4, 6, 3, 9. That's going to be 77. And then I want to add my eighth one, right? Because this is 1, 2, 3, 4, 5, 6, 7. X represents 8. When I divide all of them by 8, I get 12. So that's one way to set up this problem here as an equation. So now all I've got to do is get rid of this 8. So multiply by 8, multiply by 8, and we end up canceling that out. 77 plus X is equal to 96. Okay. That's right, right? 12 times 8. So now just subtract 77. Then X should be equal to, that's right, 96 minus 19. And look at that, 19 is our answer. So that's using the average formula. Okay. Another way that I like to do it, and this goes with, you see the question all the time where it's like, oh, you've taken 3 tests and you have a certain average, but you're taking one more test and you want to get, like, say you start with an average of 80 and on your last test, you want to score enough so that you'll get like an 85, right? So this is the same concept here, because it's all about that. They tell you that the mean weight is of 8 packages. 8 packages is 12 pounds. So what can we do with that information? Well, we know that not all of them are 8 pounds, right? If they were all 8 pounds, it'd be easy, but they're not. But because they give us that information, and we're looking for that last one, if I go ahead and just figure out, if I do 8 times 12, 8 times 12 is equal to 96. So no matter what the 8 packages are, all of them added together is going to give me 96. Doesn't matter how you distribute it. It just matters that the total weight of everything is that 96, in this case, pounds. So then now that you know that, and you can just start, whether you add all these together or not, remember these were 77, but I can just do 96 and I can do minus 25, minus 10, minus 20, minus 4, minus 6, minus 3, minus 9. And when I do that, lo and behold, I get 19. And 19 is your missing piece, your missing weight, because now all of these add up to that magic number 96. Doesn't matter how you get there, just so long as you do get there. And that's why A is the correct answer. Okay. Rasha and Scott went to a bakery. Rasha bought 4 plain bagels and 2 chocolate donuts for a total of $8.70. Scott bought 3 chocolate donuts for a total of $2.55. What is the cost of 1 plain bagel at the bakery? So the thing about this is it's a multi-step problem, and just don't get lost in the weeds on this type of problem. Just follow along as it says, and hopefully you have an understanding of how to figure it out. It wants to know the cost of a bagel. So as we look, 4 bagels and 2 chocolate donuts go for $8.70. Okay, that's good. But I don't have enough information there to extract the price of a bagel. Then it says Scott bought 3 chocolate donuts for a total of $2.55. What is the cost? Well, if I know that I paid for 3 chocolate donuts, I paid $2.55. Well, then let's go ahead and get the price of those donuts that are individual. So an individual donut's going to be $2.55 divided by 3. And so when I do that, I get 85 cents. So each donut is 85 cents. Why is that important to me? Because I bought 2 chocolate donuts up here, and then the rest were plain bagels, and now I've got my price. So with 3 variables, bagels, chocolate, price, as long as I have 2 of them, I can solve the third. And I've got total price here, and now I've got how much each donut costs. So by doing that, I'm going to go ahead and say that I have 4, we'll call them 4 bagels plus 2 chocolate donuts, which are now 85 cents, is equal to $8.70. Okay. So then 2 times 0.85 gives me 1.7 equals 870 plus 4b. So minus the 170, and I'm going to put this is going to now go up to here. We have 4 bagels are equal to, this should be $7, right? 8, 7 minus 1, 7. So we've got 7. So 4 bagels should cost $7. So then divide by 4. And we get each bagel is worth $1.75. And since that's what it's asking, what one plain bagel is worth, then you do C, $1.75. Okay, pretty straightforward. You just have to follow along with it. These are the problems that sometimes get people screwed up because you're doing like 2 or 3 steps because you're solving one problem and then you're putting it back into the other to solve it or to solve that other half. So just be mindful of the terms that they use and then what prices and where things go, because you don't want to put something in the wrong slot. Okay. This next one here says the first term of an arithmetic sequence is 5. The third term of the sequence is 13. Which of the following expressions represents the nth term of the sequence? All right. So how do we figure this out? If I've got first term and third term, and it's arithmetic, should I be able to figure out what the pattern is? And yes, you can. Arithmetic sequences deal with addition, all right? Addition, and I think you could probably do subtraction, but mostly addition. There's going to be a pattern of adding or taking away. So yeah, that would make sense. So that's what arithmetic sequence is. If I have 5 here, and then I have a blank, and then I have 13 here, we need to find essentially the midpoint. You need to figure out which one is in the middle. So if I have 5 and I've got 6, 7, 8, 9, 10, 11, 12, 13. 1, 6, 7, 8, 9, 10, 11, 12, 13. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So it's just like saying, oh, that's not right. From 5 to 13 is a difference of 8. So how do I find the number that's going to be in between these two? So if I go cut that in half, right? So if I have 8 and I cut that in half, that would be 4. So 8 over 2 equals 4. That means if I go 4 each way, so if I go plus 4 here and I go minus 4 here, well, 5 plus 4 is 9. Ooh, that's ugly. 5 plus 4 is 9, and 13 minus 4 is also 9. Well, because I've got 4 on each side, that's going to be that sequence, that missing middle sequence. So I've got 9 as the middle. Well, how many did it go? It did just like I showed you here. Oh, I don't want that. Erase this here. So if I do +4, I get 9. If I do +4, I get 13. So that's my pattern. I'm counting by 4s. So they want to know which of the following expression represents the nth term of the sequence. So with this answer choice, I want to go ahead and I want to put n in as, whatever. It can be the first, the second, or the third. So if it's the first one, so I'll put an n, or sorry, not an n, I'll put a 1 in for n. So then that's 4 times 1, which is 4, plus 1 is 5. Okay, that works. Now what if I do 2? 4 times 2 is 8. So 8 plus 1 is 9. Oh, look at that. 9 works. And then what if I did 3? 4 times 3 is 12. 12 plus 1 is 13. So we got lucky on the first shot. A is the correct answer. So you'll see it's important to do all 3 of these. And when I say all 3, like the first, second, third terms, because sometimes all of these may work for the first term or the second term. You might just pick them, but it's not going to work out for anything else. So I got 4n plus 5. Well, even if that's 1, 4 plus 5 is 9. That's going to be off a slot. So, no. 5 and 1 is 5, plus 1 is 6. So that's not going to be the first one because the first one is 5. And you got 5 plus 5 times 1 is 5, plus 5 is 10. And that doesn't happen until between the second and third terms. And so that's how you find that out fairly quickly. Okay. Just knowing what arithmetic sequence is, it's going to be the same amount adding to the next consecutive number so that you get a pattern that starts going. Okay. Next one here. For all non-zero values of x, which of the following expressions has a value of 1? So if you see that, excuse me, if you see that they're all fractions, this should be a clue. If you have 2 fractions multiplying by each other, how do we get 1? And the only way to get 1 while multiplying fractions is multiplying it by their reciprocal. Okay. So that means if I had a over b, then I'd have to multiply it by its reciprocal, which means flip it, b over a. And you'll see that either these cancel out, equal 1, or you get ab over ab, which is equal to 1 because it's the same thing. So that's the concept that we are focusing on. So then all you got to do is just go right down the line. And if you're quick enough, you can do it in your head or you can write it down, but I'll just go through them so that you can see it. You'll see I've got, remember, multiplication of fractions is straight across. So 4 and -4 is going to give me -16 over x squared, not 2x, but x squared. And so I can't really do much with that. So -16x squared is not going to work. So that's out. B says we do 4 and 1 on the top, and then x and 4x. That's going to give us 4x squared, which is going to result in 1 over x squared. Okay. And that definitely does not equal 1. So that's out. C is -4x over 4x. That's close. That's going to result in -1. We want a +1. So no go on that one because of the negative sign. So that leaves D as the last one. And so process of elimination is going to tell us that's correct. I've got 4x over 4x, which is equal to 1. 1 is the big winner. D is the correct answer for this problem. Okay. All right. And finally, it's a quick session tonight. The final question says we have Dietrich's monthly budget gives you utilities, entertainment, other, and housing and food. Dietrich or Dietrich's budgets $900 for food each month. Based on the circle graph, what is the total amount she budgets for housing each month? So if we want to figure this out, we are going to go ahead and write an equation. They give us that $900 is food. So here's our food. So how do I figure out how much food costs? Well, there was some, well, we'll start with this. There's 30%. So if I have 30%, let's do a real quickie, 30% as a decimal. Well, the decimal starts here, and then you go 1, 2, put a decimal, 0.30, or just take it in your calculator and do, because remember, percent means per 100. So you can do 30 over 100, and you're also going to get 0.30. Okay. So now that I know how to do a convert a percent to a decimal, I know that 0.30 times our entire budget, which is represented by X, has to equal, and it says food budget's $900 for food equals $900. So now I've got 0.3x equal to 900, divide by 0.3. And I should know this off the top of my head. Yeah, 3,000. So our entire budget is worth $3,000. So it's asking us, based on the graph, what is the total amount she budgets for housing? So it needs us to figure out what food is first, so that we can figure out what housing is. Housing represents 45%. Well, since we already know what the total is, it's $3,000. I can multiply that by 0.45, and it's going to give me $1,350. And you'll see that's D on the answer choice. Okay. So that's just given the information with the percent and just one of the values of the piece of pie, you'll be able to find out all the information you need to figure out the problem, to figure out what it's asking you in any of the different pieces. Okay. There's another way to do this too. If you see it, you'll learn, if you haven't already, proportions are really going to help you out in these math tests. So they give us these percentages in the chart, and then they're giving us a dollar value. So we have something that we do, it's called matchy, where you set up your proportion according to what matches on the top and what matches on the bottom. Well, in this case, you can do it either way, but I'm going to do it as, I'm going to do my percent over dollars, right? So it should be percent over dollars for the other one. Well, my percent is going to be what I know. And what I know is that I have food, which is 30. Now you can do the percent, but I'm just going to do 30, like 30% over $900. And that should equal, and we want housing now, right? Because it's all should be proportional. Housing is 45%. And I don't know what the value for that is going to be. Okay. So now go ahead and do your proportion. You can do a proportion by getting the proportion written correctly, like I have here, and then just grab your calculator, because it's all cross multiply and divide. You cross the two numbers first. In this case, it's 900 times 45, and it equals 30x. So when I do 900 times 45, I keep it in my calculator. I'm just writing it down so that you can see it. It's 40,500. And then what's the last step you do? You divide, right? So just in your calculator, you don't have to write this down. I'm just showing you. You do 900 times 45, hit equals, and then go whoop, divide 30. And you also get x equals 1350, which is the same amount that we got the first time. So it all depends on how you feel more comfortable, because that's how I always do this. I default to what you are more comfortable with doing. I don't want to change anything up. I don't want to do any of that to you. I want you to focus on what makes more sense to you. Otherwise, you're going to have a hard time when you get into the test and your brain just goes back to, survival mode, and you don't really remember how to do something that you just learned the day before. So be careful with that. But that's why I'm here to kind of show you multiple ways of doing different problems so that you can find a more comfortable way for yourself. All right. Last page is always the answer choices. So make sure you got everything correct. If you did it on your own, good for you. And if you have any questions, you can always hit us up at info@Kathleen with a K, Jasper.com. All right. So that would be any screenshots of problems that you're just having a problem with, any concepts you need help with, anything related to math. Essentially, I can go ahead and help you with that. I am happy to help you with that. That's why I do this every Tuesday, because I want to make sure that you're getting the help that you need to pass these tests. These tests are annoying, and they take time and they take energy that you just don't want to devote to. So I'm in your court. I'm here to help you. I want to do everything that I possibly can for you. So just let me know. Okay. All right. Looks like there's no comments on anything. If you think of something or something comes your way, by all means, just let me know. Shoot an email, info@KathleenJasper.com. And other than that, everybody have a great week. We're getting into the second week of March. This is good. This is spring break time coming up. The weather's getting a little nicer. I hope everything is okay in your part of the world, wherever you may be. So I hope it stays that way. With that being said, I hope everybody has a great week. Stay safe out there. If you need anything, let us know. Hit us up on all the major socials and our website. And I will see you next Tuesday. Take care, everybody.